extraction of roots. You could use either one, really doesn't matter. So what we're trying to do when we're using the square root property or extraction of roots is we're trying to isolate the square term or quantity, and from there we could take the square roots of both sides to find the solution to a quadratic equation. I forgot to mention in the beginning, we can only apply this to quadratic equations, things to a second degree. So let's start out with an example so you can get a feel of what I'm talking about. So let's say we had something like x squared minus 9 equals 0. We could notice that this is a quadratic equation because it's to a second degree. And notice that we could factor this easily. This is the difference of squares. But we're trying to focus on extraction of roots or the square root property, so let's not go about doing that. So there's really two steps that we're going to take in finding the solutions to this equation. First, we're just going to isolate the term, the squared term or quantity, which turns out to be the x squared in this term. And from there, we're going to take the square roots of both sides. So notice, to isolate the squared term, I would have to add 9 to both sides. So let's go ahead and do that first. I'm going to add a 9 here and add a 9 here. So these would cancel, and then I would get x squared is equal to 9. Okay, and we know in a situation like this, we're going to take the square root of both sides. So let me go ahead and do that. Take the square root of this guy and the square root of that. So on this side, we just simply get x. But on this side, notice every time you take the square root of something, you have to account for the positive and negative root. So I'm going to get a plus or minus 3 as an answer. Now notice, if you wanted to check your solution, you could always plug it back into the original equation to check your answer, right? So whether you plugged in positive 3 or negative 3, when you square that, that becomes 9. And 9 minus 9 is 0. So both of these solutions make this statement true. Okay, so I just wanted to write down the steps that we want to take when using the extraction of roots. So we said that we're first going to isolate the term with the squared variable or quantity. Then we're going to take the square root of both sides. Okay, so here's another example. Again, I don't want to talk about different ways that we could solve this. We want to focus on solving this by using the extraction of roots or the square root property. So first I'm going to isolate our term with the squared variable, which turns out to be x squared in this term, right? So the first thing I'm going to do is add the 45 onto both sides. Okay, so these would cancel here, and then I would get 5x squared is equal to 45. Notice the next thing you would have to do is divide by 5. Because we're still isolating our term with the squared variable. We're still on the first step. So these 5s would cancel here, and we would get x squared is equal to 45 divided by 5 would be 9. Okay, so now here we've moved on to the second step. We're going to go ahead and take the square root of both sides. I'm going to take the square root of this, take the square root of both sides, and then I'm going to get x is equal to, again, we have to account for the positive and negative root. So we're going to get plus or minus 3 again. It's the same answer that we came up with last time. So I think this method is pretty straightforward. Okay, so I've went over 2 examples, so why don't you guys go ahead and give this a shot and see how you're feeling with this new topic. Notice our squared term this time is the p squared, right? Okay, so I'm assuming you paused the video and tried this. So first I'm going to isolate our term with the squared variable, which is p squared. So first I'm going to subtract 6 over. These would cancel. I would get 2p squared is equal to 48. Then the next thing to do would be to divide the 2 since it's being multiplied here. Still on the first step on isolating, right? So these would cancel and we get p squared is equal to 2 goes into 48 24 times. Okay, so now we've moved on to the second step where we take the square root of both sides. So here I would get p equals, again we're going to have a positive and negative accounting for the roots whenever we take the square root, so we get plus or minus. Now the square root of 24, there's a perfect square hiding in there, which happens to be 4. So we could rewrite this as the square root of 4 times 6, right? Then moving over here, we get p is equal to plus or minus. Notice the 4 is a perfect square, so we could pull that out. We get 2 on the outside, 2 rad 6. So this should be the answer. And notice I've just been writing the solutions like this. If you'd like, you could go ahead and also write the solution as p is equal to 2 rad 6, comma, p is equal to negative 2 rad 6. Because sometimes professors like to see you write it this way, so I just wanted to point that out. Alright, so I just wanted to go over another example with you guys. Here we have x plus 6 inside the parenthesis, the whole thing being squared, and that's equal to 25. So when we're looking at the 2 steps, I've written down to isolate the term with the squared variable or quantity. Notice here this squared term or quantity turns out to be the x plus 6. That's the thing that's being squared, right? So it's already isolated. You know how the first step is telling us to isolate that? So it's already been isolated, so in this case we're just going to go ahead and move on to the second step, which is to take the square root of both sides. Anytime you have something to a second power, a variable or a quantity, you're going to want to take the square roots of both sides. That's how you're going to find the solution to x. So we're just going to move on to the second step and take the square root of both sides. Okay, taking the square root on this side, we'll just cancel the square term, so we'll just get x plus 6. On this side, we have to account for the positive and negative because we're taking a square root. So we get plus or minus 5. So in a situation like this, I would like to write down 2 separate lines, one for the positive 5 and one for the negative 5. So from here, personally, I would just like to go like this. X plus 6 is equal to 5, and x plus 6 is equal to negative 5, because we're going to have 2 solutions, right? So from here, focusing on here, to isolate x, we just need to subtract 6 on both sides. So we cancel and we get x is equal to negative 1. Moving on over here, we'd also subtract 6 to isolate x. These would cancel and we would get x is equal to negative 11. So it turns out that if you're to plug in these 2 solutions, negative 1 and negative 11, back into our original equation, it would set the statement true. So these 2 would be the solutions. Alright, so why don't you guys go ahead and try this. This is the last example that we have, and give it a shot, and we'll go over it with you. So this is similar to the one I did. We have the squared variable or quantity sitting right here. There's 2x minus 3, this whole thing is being squared, and we don't have to isolate it because there's nothing to isolate, right? So we're just going to move on to the second step and take the square root of both sides. So taking the square root here and here. So here we would just get what's inside the parentheses, which is 2x minus 3. going to count for the plus and minus because we're taking a square root, right? And square root of 50, there's a perfect square hiding in there, which happens to be 25. So we can rewrite this as 25 times 2. Okay, so then we get 2x minus 3 is equal to plus or minus. The 25 would come out as a 5, and the rad 2 would still remain. And personally, at this part of the problem, I would break this down into the positive and negative like I did in the previous example, right? So I would say that 2x minus 3 is equal to the positive root, which is, I'm not going to write the positive, it's just 5 rad 2. Then we also have another solution coming from the negative root, so 2x minus 3 is equal to the negative of that, which is negative 5 rad 2. Okay, so I'm going to go ahead and add 3 onto both sides because I'm trying to isolate the x. And I'm just going to go ahead and add 3 over here also. So these 3's would cancel out, and then I would get that 2x is equal to 5 rad 2 plus 3 here. Over here I would get that 2x is equal to, I'm just going to go ahead and write the 3 first. 3 minus 5 rad 2. Doesn't matter if you wanted to write negative 5 rad 2 plus 3. I just think that looks cleaner. It really doesn't matter. So, still moving on. We still haven't completely isolated the x. So now I just have to divide by 2. Notice I have to do the same thing over here, so I'm just going to divide by 2 also on this side. So these 2's would cancel out. And I'm just going to go ahead and write the solutions here. So one of the solutions we got was that x is equal to, from the positive root, we got 5 rad 2 plus 3. And then we divided that by 2. And then another solution we got from the negative root was 3 minus 5 rad 2. And then our last step was when we divided that by 2. Again, it really doesn't matter if you want to flip this around and write negative 5 rad 2 plus 3. I just happen to be in the mood to write it like that. So thank you for watching this video. This was extraction of roots and the square root property. So I'll see you guys next time.